Hello everybody! We are seeing the dramatic surge in growth and interest in the AECC's vision for driving data to deliver a new connected services evolution, where consumers and global fleets everywhere will be able to take advantage of emerging services from HD mapping to other data-intensive services. There is growing momentum for solving the data challenges we must overcome to launch an exciting new connected vehicle services era. The AECC's work will enable connected vehicle ecosystems to create proof of concept and business model that make driving safer, traffic flow smoother, energy consumption more efficient, and emission lower. What I always enjoy most about the AECC is the opportunity to network and share knowledge with the best and the brightest from across the connected vehicle industry. I look forward to making lasting, valuable connections with all of you. Thank you.
Hello and welcome. I'm Martha DeGrasse for Mobile World Live. Today we're talking about a topic that is very timely, and that is how mobile network operators can tap into the connected vehicle services opportunity. The AECC, Automotive Edge Computing Consortium, is an industry association that's tackling one of the ecosystem's biggest problems, and that is how data can be used to deliver on the promise of the connected vehicle services evolution. So we're very excited to hear what AECC has to share today, and we're joined by three expert members from the organization. We have Christer Boberg from Ericsson, we have Saeed Tibet from Dell, and Roger Berg from Denso, all here today representing the AECC. Today's presentation will focus on the emerging opportunities in the connected vehicle landscape and how mobile network operators, automotive, and cloud providers can tap into these opportunities and become leaders in the space. First, I want to provide you with a bit of an agenda. We have three things that we want to cover today. First, the opportunity and how these opportunities are developing for companies across diverse sectors. Second, we want to talk about the challenges and how you bring connected vehicle solutions to market. We're going to talk about how these challenges manifest themselves for the different opportunities that we're trying to address. And then thirdly, we're going to look at solutions, and particularly at the role that AECC is taking in terms of bringing those solutions to fruition or enabling the solutions in the marketplace. So let me set the stage. Mobile networks will enable many of this decade's most promising technologies, and perhaps no device holds more potential than the connected vehicle. As each vehicle on the road becomes part of at least one mobile network, the opportunity for operators is significant. So too is the cost of letting the connected vehicle ecosystem evolve without coordinated cooperation from mobile network operators. There is currently a tremendous amount of innovation occurring in the automotive sectors. We're looking at advancements like intelligent driving, high-definition mapping, and a variety of other mobile services, all of which have significant data demands. This creates a complicated ecosystem. It's important to think about the whole ecosystem and all the stakeholders involved, and it's worthwhile because the opportunity is significant. By 2025, all new vehicles coming to market will be connected. This next generation of connected cars will need to be equipped with fast internet access, artificial intelligence, and access to big data analytics for high-definition map creation and distribution, as well as for services like intelligent driving and more. SBD predicts that by 2025, there will be at least 400 million connected vehicles on the road, and these vehicles will be sending 1,000 times more data to the cloud than vehicles send today. To give us a sense of the economic impact of all this, GSMA has forecast that the global connected car market will be worth almost $200 billion by 2025. And according to the analysts at McKinsey, the average vehicle will generate an estimated $310 a year in connectivity revenue by 2030. In terms of the data, connected vehicles will send up to 10 exabytes of data per month to the cloud. An exabyte is 1 billion gigabytes, so we're talking about a massive amount of data sent from these vehicles. If you look at the services that the data and the technologies are used for, you're going to get a massive variety of service performance demands in terms of latency, bandwidth, etc. The conventional approach to connectivity and computing is inadequate, in the sense that we have to be paying close attention to how the data is managed given the amount that's being generated. The AECC and its members are working to identify the connected vehicle requirements needed to design the next generation of networks that can think globally and act locally. With that, I'm going to turn it over to Christer Boberg of Ericsson to share a bit more about the opportunity, emerging services, and the focus of AECC. Christer?
Thank you, Marta. My name is Christer Boberg. I work as a secretary of the board of AECC, and I'm also director of IoT and cloud strategies within Ericsson CTO office. I will start to talk a little bit about the AECC organization and our mission and vision. So, the AECC organization was created to put focus on what we call the automotive big data domain. So our ambition is really here to address what we call the key issues and challenges caused by high volume and data traffic on networks and clouds. And we estimate here by 2025, the networks and the clouds will need to manage the bandwidth of multiple connected OEM fleets. It will have to handle 400 million connected vehicles, sending up to 10 exabytes of data per month from the vehicle to the cloud. And by the way, this data is also uplink data, and it's not standard mobile broadband, which typically focus on the downstream data. So current access and cloud networks are not really optimized to handle these type of requirements of massive data loads in real time and near real time. So moreover, automotive OTMs and industry participants must identify here the best way to prioritize, collect, and process mass volumes of data from connected vehicles. So over the years here, we're going to end up with a larger problem in front of us, more than just this big data problem. We need to figure out the best way to enable business to innovate and be able to participate in this ecosystem. Each OEM, MNO, cloud provider is individually creating a unique connected vehicle ecosystem to address and overcoming their challenges. So yet each different solution creates a fragmented network function, and we could say a patchwork of technology. By 2025, all new vehicles will be equipped with connectivity. So AECC and its members are working to identify the connected vehicle requirements needed to design the next generation of networks. So as part of our continuous work, AECC has defined what we call service scenarios and use cases, which act as a baseline of what AECC envision, and it represents a number of so-called model use cases, where some examples we will talk about here. One of them is intelligent driving. In this use case, the cloud application will collect data related to the vehicle and the driver, and that could be data such as cruising data from the car. It could be driver biometric sensor data. It could be other type of vehicle control data. And this data is then used to compute what we call the intelligent driving parameter set using, for instance, advanced machine learning technologies, and insights and instructions based on those algorithms is then sent back to the vehicles and drivers in real time or near real time, depending on the type of information. Another use case of importance is the high definition map. An HD map consolidates different static and dynamic information. That type of data could be vehicle position, it could be pedestrian information or position of pedestrian, and other type of dynamic obstacles. This would mean that a large amount of data is transferred and required, especially to update the map. And this data is collected from a number of things, such as the cameras, the radar sensor, the laser scanners, the lidars. And this is transfers and processed in the cloud, and updates is then sent to the vehicles in focus of that particular geographical area. A third use case of importance is what we call the V2 Cloud Cruise Assist, or we also call it V2V to Cloud, vehicle to cloud, which is a model use case where the network mediates the vehicle to vehicle communication. And it does so by integrating information obtained from neighboring cars. So vehicles transmit their cruising data to the cloud to be analyzed, in order to provide information for driving assistance or similar. This generated information will then be distributed to relevant vehicles and possibly also other roadside facilities in these neighboring areas of interest. Apart from those three model use cases, there are other services that will benefit from the automotive big data. And those are, for instance, mobility as a service and finance and insurance use cases, which could enable, and this data could enable new type of intelligent services like ride shares and car-based data from vehicles. Now, when we have talked about these use cases and the big amount of data that they represent, we need to look at ways to manage this data in the most efficient way. And in order to manage these volumes of data in the best way, we want to process the data closer to where the vehicle is moving to benefit from shorter latency and better transport paradigms. So AECC have defined what we call a model for a local distributed edge computing cloud architecture that will speed up data processing and reduce transportation of data by matching compute resources with the vehicles that actually needs the data. And in the context of edge computing for automotive use cases, edge means what we also call the hierarchically distributed non-central clouds, where computation resources are deployed, and edge computing technology can be used to design a more flexible and topology-aware cloud infrastructure, meaning that there is no specific definition of where that data is put. It depends on where it's best needed. And when we look at the opportunity here of the localized network, we see that this architecture represents and creates an opportunity for mobile network operators to host edge service running these cloud-based applications. Today, the cloud is dominated by a handful of cloud players, but at the edge, MNOs and their data center providers have a good opportunity to participate given their position as managers and owner of the network access points. As mobile operators now invest in edge servers meant to host applications, the goal is typically to support mobile subscribers, standard consumers. But within a few years, this infrastructure could and should support not just what we call mobile, but also mobility. And mobility is the connected car ecosystem that we also call the mobility industry. These near futuristic features will then rely on the collaboration and cooperation of many different ecosystem players. And that includes the automotive OEMs, of course, and the mobile network operators and the cloud providers, but also other actors in the IT space and application providers. And finally, we should also remember here that automotive industry doesn't only require, well, we should remember that 4G and not only 5G is highly important for the automotive industry. And also that we have what we call global consistent solutions, which would give the connected vehicle ecosystem an ability to utilize this mobile network in a stringent and consistent way on a global scale. And we should also remember that the more features we add to the networks and the system, the more complex this will be. And it's even more important than that for standard and best practices and blueprints provided by, for instance, the AECC collaboration. One important aspect of AECC is how do we measure success? How do we get our result out to broader audience? And one way of doing that is, of course, to first of all produce technical reports and white papers. But it's also very important that we will see later on when we talk about proof of concept that our technology and our recommendations are used, and that you can measure that the proposals are valid and useful. And one way of doing that is, of course, in proof of concept. And one example is where Toyota, Ericsson, and Vodafone got together to actually implement a function to prove and show that the edge compute gives improved value compared to standard cloud computing. And by the way, Vodafone is not a member of AECC, and still the usage of the technology reports are of high value and can be used then, of course, of non AECC members. And that is a big value for us. We want our technology and reports to be verified and used. Thank you. With that, I hand over to my colleague and friend Saeed Tabeh, who will talk more about a specific function on HD mapping. Thank you.
Hello, everyone. It's a pleasure to be here, even though it's virtual. First, I'd like to thank the organizers for bringing us all together to share our knowledge and exchange ideas and inform about the work that's been ongoing. My name is Saeed Tabeh. I am one of the board members from the Automotive Edge Computing Consortium and a member of the Global CTO office at Dell, where I focus on automotive as well as edge computing, robotics, and AI and digital twins. So it's a pleasure to be here. As we explore these ideas around the work that we're doing, HD mapping is one important use case. And I wanted to kind of, what we see on the screen, give you a little bit of information around the definition, the approach that we took within the AECC, and also the structure that we're proposing in terms of the layering of the various elements of HD map. So let's talk first about the definition. An HD map, you'll find out that different organizations have different definitions. And these kind of changes or definitions are based on obviously data volumes and other types of elements or concepts that are introduced. A map overlaid with various information such as traffic, access ways, and street furniture with city streets and subsurface ducts, and with high precision, which is really important to have that kind of enablement. And this needs to be at the centimeter level, if not less, if possible. And the updates have to be frequent. So that's also really important in terms of synchronization. So in automotive use cases, the HD map is key. In fact, it's really important for services such as autonomous driving that require them. And they do require them with resolutions of 10 to 20 centimeters, and better if we could enable that. In the future, vehicle big data, such as the video data, pictures, images, 3D LiDAR, and any other sensory data that comes out of the vehicle, this motion data will be collected from millions of vehicles around the world. And this data will contribute to these HD maps and to their precisionness, to their level of usefulness, in order to assist with what I was just talking about, autonomous driving, automated services, etc. As more vehicles and their sensors are deployed, the challenge that would come up is how to handle the data, how to extract the salient, the relevant information from it, and focus on that, because that could be expensive, it could be hard to get, could be too much of it. And new types of ICT infrastructures are going to be needed to handle such volume, what we call the zettascale infrastructure. These volumes of data are needed, obviously, not only to support, but also to maintain these HD maps over time and to bring value to the consumer, to the users of this data. So on this slide, we'll give you a little bit more detail. And actually, it's a journey when you think about it around the layering of this definition, what an HD map is made of, the composition, if you will. And this is our recommendation, the 4 layers. In many organizations, which simply suggest an HD map is just one static layer and then many, many dynamic layers on top of it, we feel that quickly becomes very complicated, and it creates a number of challenges, and it's not really well defined in regards to what the data type is, how many layers it should be, what are the time intervals, and this is kind of where AECC has been working really hard to figure out a solution that can be simple, easy to implement, and gets us somewhere closer to a level of standardization, which is really important for the industry, for the community. And that's kind of what you see on the screen. And let me go through these quickly. I'm going to start from the bottom, right? 4 layers. When you look at the picture, really what you're going to see also is that the time intervals and the real time increases as you go from the bottom to the top. And you'll understand that through the examples I'm going to give you. The bottommost layer, which is called the permanent static layer, has information which changes on the order of days, or even longer in some cases. Right? Examples like road constructions, we could take days, weeks, months in some places, or city blockages that can be there for a certain amount of time, or any kind of that level of information, if you will, is maybe closest to what many organizations define as static layer, and similar to the routing kind of layer that you use currently in the map that you will get in your current maps in your vehicles. Now, if we go to the next level from the bottom, again, this is what we call the transient static layer. The information or the dynamic information changes on the hourly basis. That's the time interval, right? Like major road accidents, broken down vehicles, or things that could be there just for hours. The change, obviously, in here still has some level of dynamic aspect to it. And you'll find that, in fact, in all of the 4 layers, right? Even if you're weeks or months, it's still dynamic. So from the one more thing I want to point out really here, this is a simple solution, right? The 4-layer approach. The HD map does not want to focus on events which occurred less than 1 second, because they are simply too dynamic in nature and very hard as far as the amount of information that needs to be gathered and raised to an HD map level. So that's kind of a little bit more complex. The 3rd layer, which is labeled the transient dynamic layer, this is where the information changes on the minute level. So we went from days to hours to minutes. Examples like certain obstacles, illegally parked cars or something like that, they could be there for a few minutes and then they move on. Finally, when we go to the top layer, this is where the highest, really called the highly dynamic layer, this is where the information changes on the second interval. It's almost like the notion of real time in some ways. Think about traffic patterns or pedestrian patterns around the vehicle. As I said before, the more we go from the bottom to the top, the more the real time increases, and the more the amount of information, the amount of data that needs to be registered for the HD map changes, and the information flow will increase even more, and that's as you can imagine. And this is really important. As we said, we are not focusing on the sub-second or milliseconds or things like that, as you can think that these types of events would require more complexity, as opposed to what we're talking about here in terms of seconds to minutes to hours to days. Again, thank you. So with this, I gave you a little bit of an overview of the HD map as a use case. It is my pleasure to introduce my colleague, Roger Burke, who's going to take us through the next set of slides. Thank you again.
Well, hi, I'm Roger Berg with Denso Corporation. I work in our North America Research and Development Group on automotive connectivity, cybersecurity, data analytics, and a host of other things. This is the process we follow in AECC. First, we develop use cases and user stories that turn into requirements for the mobile edge computing network. Then a second working group develops possible technical solutions that they believe will effectively address the use case requirements. The solutions, or portions of them, come from a number of different players within the AECC community: MNOs, network equipment providers, data storage equipment teams, among others. Then finally, we advance to a proof of concept, or POC mode, where the working group develops demonstrations of the technology approaches to show that AECC solutions are realizable in the wild, not just in special cases in the laboratory, and that they satisfy the original user scenario requirements. From the perspective of the work done in AECC, all the member companies can contribute at any level, from creating requirements to finding technical solutions, or even just focusing on the demonstrations, which are one of the AECC's most important windows to the world. Our POCs are visible exhibitions of the work that goes on during the constant and intense level of collaboration within the AECC community. To show our capability and validate that we're not just about researching communications and computing theory, we should, and do, demonstrate real-world usefulness, and that's exactly why we have our POC working group. On this slide, we describe 2 examples of the handful of demonstrations currently under consideration within the POC group and its leadership. The first candidate concept comes out of work done in the AECC that some of its members have performed on data transfer by cache control. This came from when our automotive sector community teamed up with one of the AECC's MNOs to show that available network resources can indeed match up with the service requirements of a particular use case, and at the right times. It illustrates one of the fundamental capabilities of network edge computing and is further described in one of the technical papers from our working group 2, as is shown here. In that paper, we introduced the concept of opportunistic data transfer, and our proof of concept demo illustrates a practical, real-world solution. The second candidate deals with distributed data management in a more general edge computing case and introduces the concepts of distributed data access acceleration, a digital twin data management platform, and near real-time data integration. These requirements and candidate solution techniques are further described in a couple of our most recent white papers, as you can also see here. The AECC has a plan to continue to develop proof of concept demonstrations as we add more use cases and create additional technical solutions that support new requirements. Further information and example demos of these concepts can be found on the AECC website, with the link shown here at the bottom of the page. Please continue to use this as a resource for you to locate and follow updates to our POC roadmap, as we have plans to show additional live public and virtual demos in the future. We want to be sure that the community of participants in the AECC all have the chance to share their ideas, their capabilities, and their contributions towards building an effective ecosystem of mobile edge computing solutions. We want to provide a robust answer to the mobility domain's connectivity and computing applications requirements questions. We've been talking here about the process we use. By that I mean creating original and novel use cases from the transportation user perspective, translating them to resilient and sometimes unique technical solutions, and either publishing white papers describing those or engaging our POC group in demonstrating that our solutions are realizable and that they do work for creating the future of mobility. We really count on the different perspectives of our member community to create meaningful use cases, sturdy and resilient mobile edge computing technical approaches, and clear delivery of that value through our POC program. It is our mission to bring together the best minds from the MNO, OEM, cloud services, and technology provider communities to realize robust solutions that benefit people and companies that use mobility systems around the world. Here you can see some of the titans in this mobile edge computing industry who have been effectively collaborating within the AECC since 2018 and continue to do so today. We are in an exciting time in our evolution, creating important industry consensus use case ideas and technical solutions to be used around the globe. And yes, we want you to be part of it. Please join us in our journey towards a mobile edge computing future and make your own contributions to our community while learning new things from the other members, as we hope you would become actively involved in one or more of our working groups. I think now that I'll turn it back over to Martha to sum things up and lead us into the next steps. Thank you.
Thank you, Krister, Saeed, and Roger for walking us through those presentations and sharing a bit more about AECC's work. In summary, I think we can say that the opportunity is massive. There's no denying that. At the same time, it is a very complex ecosystem when you're bringing together industries like the communications industry, the automotive industry, providers of computer infrastructure, and then broadening it out with insurance, finance, vehicle services, etc. When you look at that kind of ecosystem, it is incredibly complicated. The AECC, in conjunction with Mobile World Live, recently published a white paper talking more about these issues. It's called Connected Cars on the Edge of a Breakthrough. It looks in more detail at what is needed to bring some of these solutions to market and how the AECC is enabling that to happen. This report provides a lot more detail into what we've been talking about today in terms of how the AECC is contributing to the development of the connected vehicle market. You can visit the AECC Mobile World Congress resources page to download that material. And now I'd like to take a few questions that have recently been submitted. Okay, so Krister, Syed, Roger, these questions are for all of you, so feel free to jump in. And the first question is a big one. Who is likely to own the data generated by the connected car? Will it be MNOs, OTT service providers, consumers, vehicle OEMs? Will it be vehicle finance companies? And how will data be made available for enterprises to use in automated decisioning in real time?
This is a really good question, and it's a question that's been debated for a while now. I definitely feel that there is no one single answer, and it's a two-part question. Obviously, let me first take a stab at the first part. Who owns that data? And there's so much of it, as you saw when I was talking about the HD maps. The data that gets generated, some of it is definitely data that should be owned by the OEMs, or at least made available to them. Particularly if we're thinking about data related to the vehicle health, or related to some of the aspects that helps them improve the vehicle safety or improve the vehicle product elements or components, etc. Other data may be owned by the MNOs to better understand how they can service in terms of making this connectivity and this ecosystem enablement a lot better. Other data may be owned by consumers. So like I said, it's not an easy answer. I think we need to figure out a way to facilitate the availability of that data so that the proper owners can actually leverage the value out of it, and make it in such a way that, of course, it's secure and safe, and also equally important, obviously, respecting the privacy, the PI aspects of it, or any kind of regulatory elements, depending on what region this is taking place. So that's really important, and I think it's a complex problem, and I hope we continue to work on it as an industry, but we continue to work on it as an ecosystem overall. Yeah. The second part of the question now, it's quite complex. So to enable the use of that data in real time is a challenge in itself, because we're capturing data and making it available. There are a number of examples where this is really important from a safety point of view, for example, or reacting to certain event, or even facilitating the experience of the users, of the consumers in the vehicle, whatever that vehicle usage is, whether it's for transportation or for other things. I think that's really important to enable that capability, and that's work that needs to happen in collaboration. There's no one single group of companies or one area of the industry that can enable that. We need to kind of work together in defining standardized architectures and capabilities to deliver services that can be consumed in a seamless way across the industry. So I think that's really important. And I would say it's still a big challenge. We always talked about the ZS scale in terms of the data. What's relevant to you? How do we capture what's needed to be able to respond within that criteria of real time if possible? Yeah.
Thank you for that. The data is obviously where a lot of the value lies here. Now let's switch gears. How important is the adoption of Universal Integrated Circuit Cards, ESIM technology, for the development of the connected vehicles market?
Yeah, that's a great question. So when it comes to the evolution of eSIM or AECC, we see from the perspective of automotive that's an essential technology. If we can look at from the start, from machine to machine profile, via consumer profile, and now for IoT SIM profile, that the industry will have a need for what we call a localization of subscriptions. And if you compare with the consumer or end user, the consumer mobile broadband, there is a difference, because there you typically have your home sort of, you have your home address and you work with a single operator. If you look at the global industry, that's not really the case. They have a global industry, fleets go everywhere, and they will have to use with access network, mobile access networks all over the world. And as we have talked about the high volume data and also the low latency, the classical roaming model or home routing model is not really suitable for those type of use cases, which would require some kind of local breakout in visitor network, or that you actually localize your subscription in the visited network, so to say. So we absolutely see that that is an evolution that will be needed, and there might be other things that need to be done as well, such as an improved roaming model. But nevertheless, eSIM is here to stay, so to say.
Well, I think as that technology begins to be deployed and as it's being used and understood how to be used by the equipment manufacturers, and in our case, the automobile manufacturers who have embedded modems that use mobile edge computing, I think that will be taken. There will be an advantage to the end user, where they can pick automatically, or it can be picked or decided for them, which of the mobile networks that is currently in the region that they're traveling through is the best one to fulfill the needs of their services on their vehicle. And so I think that the ability to switch between mobile network operators and service providers, depending on where you are in a country or in a city or in a state or in a county, or no matter where you are, you will get the best service as a user, as an end user. And I think that will be better off, will make a better user experience for everyone who's using mobile edge computing.
Thank you. What role do you see micro data centers playing in the connected everything ecosystem?
That is a great question. As we started to see the fantastic evolution on the capabilities around cloud computing and data centers and compute in general, right? And then now in the recent year or so, where IoT and then edge computing is becoming more and more important, definitely this concept of a continuum, right, in terms of the compute, or being able to deal with the data where it is, right, bring the data to the compute, if you will, is very important. It comes, of course, with benefits and challenges. I think the role is important. We don't want to, we can't afford in some of these use cases to wait until data goes all the way back to the cloud and comes back to us. So there are cases where it's really important to be as close as possible to the compute capability, whether it's in the vehicle or next to it. So these micro data centers or edge or what we call roadside units, etc., are going to play an important role in contributing as part of the overall system of compute and storage of data and communication, etc., the overall kind of architecture. They are very important to make sure that we can deal with some of these challenges around latency or latency sensitive use cases, right?
That's interesting. Now, in high-speed environments, there is a handover every couple of seconds. How will it affect the scheduling of resources at the edge, and how can it be optimized?
Well, that's a really good question. And this again goes to kind of an optimization of where the computing and communications partitioning has to take place. In a high-speed environment, yes, of course, we're going to change maybe the base station itself, but that doesn't necessarily mean we need to change the computational center for where the services are being are using the mobile edge computing. And so if we can effectively route the data that's churning from base station to base station or cell site to cell site, but still keep it in a computationally sound and localized manner, it may be that the user will not see the continuous change of the cell towers, just like it doesn't in a conversation today. And when we're talking about mobility, IoT, and machine to machine, I think that can even be better scheduled and more optimally partitioned again by using some of the techniques that we're studying in AECC, presently.
Okay, thank you. Now we're going to talk about MEC, multi-access edge computing. What kind of solution do you see OEMs leaning more towards? A private MEC with a telco or a public MEC with a hyperscaler?
Yeah, I don't know. I think it's both, depending on sort of the choice of the enterprise or the OEM in this case. There might be different, and also again back to the use case discussion. It depends on the use cases. My belief is that you will see it all. There will be need for what we call a public cloud or hyperscale edge solutions, and there will be need for private data center MEC centers. So yeah, again, I don't see a clear answer that it will be either or. There are places for all of the aspects, all of the possible deployment models here, and it will be a choice, of course, between both the OEM and also the access network provider, the MNO.
I think both are in the recipe from the OEM's perspective. I don't think they've really figured it out yet, and I think they're going to do some experimentation, put some test beds together, and really try and find out. And this is kind of the exact activity that the AECC wants to be involved in, is to test these solutions about, do I need a private network? Do I need my own private MNO, or can I use, or can I bounce between MNOs and use the best service that completes the needs for my microservice or my application in my vehicle as I move through these cities and towns and states and counties and what have you, regions. And so I think that it's a little bit early to be able to answer that question truthfully, without a little bit of experimentation and a little bit of I would say, test bed data that gives us real numbers, as opposed to just taking guesses at what might be the optimum.
All right, thank you. Next question. How will existing third-party telematics compete with and or merge with emerging first-party telematics driven by some OEMs? Could the two players jointly serve for commercial fleet customers and individual passenger car owners?
Well, I see the what you might call the aftermarket, or the second, I think it was called the second party telematics service providers. I think you could see that becoming up very big in fleet ownership, because it's almost never the case where an entire fleet of vehicles that might be used for delivery or rental cars or car sharing or ride sharing would be from a single OEM. And so that fleet owner has to understand how their cars are working, how their cars are operating, where their cars are at, and to try and put together 6 or 7 different OEMs solutions, first level solutions, I think you called it, into their own package of how they're managing their fleet is an arduous task, if not impossible task. And so I think the third party telematics, or second party telematics, however it was said in the question, will provide a very beautiful and nice service for fleet owners that have a heterogeneous collection of different OEM solutions for their vehicle fleet.
Sai, do you have anything to add on that?
That is a great question as well. I'm a big fan of enabling ecosystems. This is as we move towards more and more, I would say, autonomy, not automation. I've been doing that for a while. We're going to need all these players to contribute to that ecosystem. And I'm a believer that we can solve that problem together, because it's very challenging. I think we need as much data as possible. That example of HD maps is one of them. And it is beyond just the driving. It's also being able to be in a vehicle that will take someone to a clinic and starting to capture some of that data even before they get there, for example, or being able to deliver goods and other things to remote locations, etc. So there are many different kind of use cases where you might find in this overall ecosystem a lot of different players involved. I think it is in the interest of the community, the industry, as we improve to be able to innovate together. And there is definitely room for obviously the third parties to contribute from a telematics point of view with their own solutions and their own way of managing data and capture of that information and bringing their own perspective. I think it'll be beneficial to the OEMs, to the consumers, to the enterprises that are leveraging that information from both sides. Yeah.
Thank you. Now, how important is 5G for the connected vehicle market?
I think when we talk about 5G and connected vehicles, we see that synergy, right? As we get closer to more kind of mass deployment of these vehicles, as we start to have more adoption, we are going to need that capability more and more. We're going to need it, and we, in how we would use it, but it's also in terms of how it would respond to some of the tough requirements of automotive. As we say from an AECC point of view, or in general, the zettascale, these very large sets of data are going to be experienced in this world, in autonomous vehicles, in connected vehicles. And I think 5G will help in dealing with this challenge specifically. But it would help in doing it in a way that would also facilitate the other capabilities, right? So it's part of an overall solution in terms of the being smarter and more intelligent about how these communications and these connectivities are going to happen. So I think it's very central in terms of its role. It's very important with the challenge itself, and it would contribute as part of an overall solution. Yeah.
Krister, do you have a perspective on that?
Yeah, so as we talked about before in the presentation, 5G is, as we know, 4G was the, so to say, the mobile broadband for the consumer market, and 5G is the mobile broadband for industry, meaning that when we go forward, we will see a lot of more new functions, better speeds, lower latency, more spectrum, and a number of different things like slicing, etc., network exposure that you get from 5G. So we are absolutely certain that 5G will play an essential role of the connected car ecosystem's evolution. But as we said also in the presentation, the automotive industry is global. The automotive industry, connected vehicles are moving around everywhere, meaning that to utilize the functionalities of 5G fully, you would have to have 5G everywhere, which obviously what we would like to see. But that means that 4G will be an important aspect of the connected vehicle ecosystem for a foreseeable future. Meaning, and also that what we have done in AECC, of course, is to define, for instance, edge management, or how you handle edge is not only how we handle it in 5G, but also how we handle it in 4G. And going forward, of course, we will see that 5G replaces 4G over time, but for now and for some time, that will be a complement, so to say, to the current mobile broadband coverage, if you say.
Roger, what do you think about that?
Well, obviously, well, maybe it's not obvious, but I think a lot of people understand that as we have had with 2G, 3G, 4G, 5G, and we will have eventually with 6G, the proliferation of network subsystems won't cover everywhere on day one. And so I think a lot of the services that the mobile ecosystem providers want to have available for their customer base can't depend on just this new G, so to speak, to deliver services. we have to look at where the wide-scale proliferation of connected services are, and adapt the capabilities of that network and those legacy computing systems, or adapt them or retrofit them to enable some of the mobile edge computing solutions that we're talking about for 5G, but enable their usage on a 4G system. Because in a lot of areas, at least in the United States, and I would say probably from a global perspective, a lot of the areas that people drive are not where 5G is the most economically sound solution. So we have to, as a mobility community, we have to rely not necessarily on the latest G and the latest high speed, high availability, high reliability specs, but also cater our services towards the previous G, if you will, where all of those spectacular specifications are not realized in every region that a roadway is put down on the ground.
I'm sure we'll be hearing more about that down the road. Thank you. Now, how does the AECC differentiate itself from all the other consortia and standards development organizations that are looking at 5G, edge computing, and automotive services?
That is a great question, absolutely, and it's an important one, right? Because we all play a role as an overall ecosystem as we go into this next level of evolution overall. The autonomous connected vehicles, mobilities in general has an impact that is horizontal across all kinds of industries and society in general, right? So when we look at it from that perspective, the AECC has taken a role in trying to solve this big data problem, right? We're not looking at some of these other elements. And in fact, as a result of that, we started to build these liaison relationships with 5GAA, with 3GPP, and with IAC, with a number of other players, so that we can actually all collaborate, share what we learn from them, and they learn from us, so we can solve that problem. So really, it's important to make sure that there is synergy from that perspective, and it's beneficial, of course, to the industry. It's beneficial to the consumer of the technologies, or even the ecosystem. And from our perspective, this big data problem, this zettascale problem, is a major one, and we want to tackle that. And we've been generating white papers and technical papers and other communications to help support that, and working closely with the other players. Yeah, thank you.
We consider mobile edge computing as a combination of the access to the network and the way the network flows data and uses the computing resources to process that data in an optimum way to provide for those services. Number two is, I think the AECC is focused not on all aspects of 5G or 4G or 3G, or not all aspects of mobility, so to speak, but really on the mobile edge computing section of that broader landscape of connected vehicles. And so I think we can afford to focus on those particular use cases that take advantage of the mobile edge computing and the solutions that we are providing that will be useful for not just the mobility domain, but also other possible adjacent markets, like virtual reality, or other kinds of enterprise use cases that take advantage of mobile edge computing. That would be the same solution as what we would look for in a mobility scenario, in a transportation scenario. So I think that AECC has some unique aspects that make it different from some of these other organizations. Not that we're any better or any worse, we just take a different perspective that focuses on mobile edge computing. And we are radio access agnostic.
Thank you so much, Christer Boberg from Ericsson, Saeed Tibet from Dell, and Roger Berg from Denso. Hopefully next time we'll be meeting in person. In the meantime, be sure to check out the AECC Resource Center linked below. Stay safe, and thank you so much for joining us.
Consumers and global fleets everywhere want to take advantage of connected services, and the AECC is driving data to deliver the next generation of connected vehicle services. In fact, by 2025, every new vehicle is expected to be connected. More than 100 million connected vehicles will come to market, joining the hundreds of millions that are already on the road. Connected vehicles will send up to 10 exabytes of data per month to the cloud, 1,000 times more data than today's networks are accustomed to handling. Yet, today's networking computing systems aren't optimized to handle this volume of data in real time.
Emerging connected vehicle services will need to serve fleets of connected vehicles as well as the next generation of connected cars in real time. Manufacturers, mobile network operators, and cloud providers need stringent connectivity over a global scale to deliver future services, along with the networking and computing systems to handle it all.
The AECC's distributed edge computing approach puts data processing closer to the vehicle's location, utilizing localized networks and edge computing near where the vehicle is moving. Data processing volumes are prioritized and reduced, enabling connectivity speeds to meet real-time demands. The AECC's approach enables an entire ecosystem to create and deploy next-generation services such as intelligent driving, HD mapping, V2 Cloud Assist, mobility as a service, and finance and insurance services to millions of vehicles and fleets. This approach will help OEMs, MNOs, cloud, and service providers create new proof of concepts and business models that work to make driving safer, traffic flow smoother, energy consumption more efficient, and emissions lower.
The AECC's goal is to understand and document how such a huge amount of data from the moving device such as vehicle can be computed and analyzed in the location nearest to the roadside, and then how quickly we can react to the vehicle's surroundings in the environment by introducing an edge computing in a network or near the vehicle's location. The connected vehicle ecosystem can generate a lot of value from the data.
AECC members play an essential role in accelerating innovation. AECC members are leading organizations with a shared passion for the connected vehicle ecosystem.
Our working groups and member meetings are focused on bringing emerging services to life. Services such as intelligent driving, the creation of maps with real-time data, and driving assistance based on cloud computing require vehicles to be connected. The AECC's new technical and use case guidance is a playbook for how car OEMs, MNOs, and cloud providers can help evolve networks and edge computing for connected cars. We published version 2.0 of our technical report. We published version 3.0 of our general principle and vision white paper. And we published the HD map white paper. There is no other organization like AECC, none that has the breadth and depth of our leadership and that also provides opportunities to provide guidance to industry and standards development organizations.
There has never been a better time to join the AECC. Get connected with automotive OEMs, mobile network operators, cloud providers, and application and services organizations working to accelerate the growth of the connected vehicle market. Connect and learn more at aecc.org.